friends, welcome to another video in our binary tree series. I'm Chinyelu, a software engineer at Microsoft here in Dublin, Ireland. Today we'll be solving path sum. This will be the last easy question we'll be solving in this series, and I'm going to be solving this particular question using the breadth first search approach just because it's been a while. All right, let's get started. Given the roots of a binary tree and an integer sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf is a node with no children. All right, so this question is very simple. We just need to traverse the tree, summing up the values of the node along a path. And once we get to any leaf node, we check if the sum we have so far is equal to the target sum. If it is equal to the target sum, we return true. Else, we continue our traversal. And if we traverse the entire tree without getting a sum that equals the target sum, we will simply return false. So the key thing here is to traverse and sum up node values while at it. Just like in this example, we can see that this is a path, and the sum of all the nodes in this path equals to our target sum, which is 22. So we return true. Remember, you can traverse using any traversal method of your choice, breadth first search or depth first search. If you're not very familiar with tree traversals, please check out my video on tree traversal. Now, straight into the business of the day. The first thing will be to return false if the root node is null. The next thing is to begin our traversal by initializing the queue. So the queue will contain array elements made up of the current node and the sum so far. Traversals start from the root. So the first element of our queue will be an array containing the root node as the node, and then the root node's value as the sum so far. We now loop through the queue. While the queue is not empty, we dequeue the first element from the queue and retrieve the current node and the current sum. We then check if the current node is a leaf node. A node is a leaf node if it has no children. That is, the left child is null and the right child is null. So if the left and the right child of the current node is null and the sum so far, which is current sum, is equal to the target sum, we just found our answer, so we just return true. Else, we continue our traversal by pushing the next node into the queue. Of course, we will only push nodes that exist into the queue. So to take care of this, we check if the left child of the current node exists. If it exists, we create the data to be added to the queue, which will be an array of the current node's left child and current sum plus the value of the left child. Then we push this newly formed array into the queue. We repeat this for the right child. So if the right child exists, we create the data to be pushed into the queue, which is the current node's right child and current sum plus the value of the right child of the current node. Then we push this newly formed array into the queue. At the end of the loop, we return false if we are unable to find a path that sum up to the target number. Let's run and submit the code. Good job! Finally, let's talk about the time and space complexity of the solution. The time complexity of the solution is of course O of n, where n is the number of nodes present in the tree. Because in the worst case scenario, we will have to visit all the nodes present in the tree. And also, the space complexity is equally O of n because in the worst case scenario, the queue will contain all the nodes present in the queue. Thank you for watching till the end. If this video was helpful, please give it a thumbs up and hit the subscribe button to see more videos like this in the future. If you want me to solve a specific binary tree problem, leave a comment below and I'll add it to my list of videos to create. Thanks again for sticking till the end and see you in my next video. Bye!